With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start this question. In this question we are given with the reaction that is small a plus small b is in equilibrium with small c and small d. Also we are given the equilibrium constant that is kc, kp and kx. Here kc is with respect to the concentration, kp is with respect to the partial pressure and kx is with respect to the mole fraction. Also we are given the values of these equilibrium constant that is kc is this and we are given the value of kp and kx or kchi. Now we are given A represent the molar concentration of A, PA represents the partial pressure of A and P represent the total pressure and XA represent the mole fraction of A. Now we have to choose the right option. We are given the relations between these Kp, Kc and Kx. Now firstly we will write the reaction that is small a plus small bb is in equilibrium with small cc plus small dd. Now if we write the value for the equilibrium constant with respect to concentration, it will be the concentration of C raised to the power small c, D raised to power small d, it will be A raised to power small a and B raised to power small b. So this will be the value for the equilibrium constant on the basis of the concentration. Now we know that the value of Kp, that is equilibrium constant in terms of partial pressure, will be partial pressure of C to the power C, partial pressure of D to the power D divided by partial pressure of A to the power A, and it will be, here it is missing that partial pressure of B to the power B, so we will write it as partial pressure of B to the power B. Now we know that from the ideal gas equation PV is equals to nRT, so we will calculate the value of P. It will be equal to N by V RT. Now also we know that N by V is the concentration in terms of molarity, so it will be represented by P gas, C that is concentration, RT. Now we will write this in the Kp formula. We will put down the values. It will be Kp will be equal to concentration of C, CRT to the power C, concentration of D, R, T. R is the universal gas constant, T is the temperature, to the power D, and similarly A, RT to the power A and BRT to the power B. From here we will get that it will be C, D to C to the power C, D to the power D, A to the power A and B to the power B, and we will write RT as common, that will be C plus D minus A plus B. Now we can write this C plus D minus A plus B as the value for difference in number of gaseous mole, as we are given the reaction is in gaseous state, so we will write it as. Now also we can see that this is the value for Kc, so we will write it Kp will be equal to Kc into RT to the power delta Ng. So this will be the relation between Kp and Kc. Now let us move forward. Now we know that equilibrium constant with respect to the mole concentration, that is Kx, will be equal to Xc to the power C, Xd to the power D, Xa to the power A and Xb to the power B. So this will be the value for the equilibrium constant in terms of mole fraction, that is we are given with. Now we know that we can write the partial pressure of a gas as mole fraction of the gas into the total pressure, so also we will write this as the partial pressure in the formula of Kp. We will use the formula Kp, that is equals to partial pressure of C to the power C, partial pressure of D to the power D partial pressure of A to the power A and partial pressure of B to the power B. We will put down the values. We will get xc to the power c. We will take pt as common. It will be, firstly we will write xc pt to the power c, xd pt to the power d divided by xa pt to the power a and xb pt to the power b. So it will be equal to, we will write it as xc to the power c, xd to the power d, xa to the power a and xb to the power b, and we will write pt as common. It will be pt, that is the total pressure, or we are given total pressure as only p, so it will be p into c plus d to the power c plus d minus a plus b. Here also it was in bracket, so it will be, now we know that this is the equilibrium constant in terms of mole fraction, so we will write it as kx. So kp will be equal to kx into pt to the power, this is the difference in the number of gaseous mole for the product and reactant, so it will be represented by delta Ng. So this is the relation between kp and kx. Now we will check the options we are given with. Now in the options we are given kp is equals to kc RT to the power delta Ng. This is correct, but this is incorrect. Now in second option we are given kp is equals to kc RT to the power delta Ng and kp is equals to kx p to the power delta Ng. This is correct answer. So this is the solution. Thank you so much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.